This video is part of a series. Complete the previous videos in this playlist before you start this video. The complete playlist information, the material and the code file information is given in the video description below. If you want to become a good data scientist, then having good knowledge in Pandas is absolutely necessary. Pandas is a huge package with so many sub packages in it. There are so many important functions, sub functions that we need to learn and understand. A lot of them we need to master them. Let us try to understand some of the important packages, important commands, important functions within Pandas. This session is on Pandas deep dive. Let us get started. So let's start with the first exercise. What is it? Importing dataset into Pandas. Importing, we have already seen a couple of times. How do you import? Let's say if you are importing it from a CSV file, you simply write pd.read_csv, and then you write the complete path along with the file name, along with the extension. You can import the data from various resources. You can import it from CSV files. You can import the data from Excel files. You can import the data from databases. You can import the data from Hadoop distributed file system as well. Nearly 30 to 40 different type of data sets can be imported very easily in Pandas. So let us get started with importing of our first data set. Let's get started. So import pandas as PD, okay. And the data set that I want to import here is, let's say, sales data. So how do you import the sales data, or World Bank data is what I want to import. Let's import our first data set, sales data. So how do you write it? pd.read_csv. This is the complete path to the location where the file is, CSV file. If you execute this, and then you will get the file imported. Not only the CSV file, you can import Excel files as well. You can import SQL files as well. Like SQL file in the sense, you have a database and then you can connect to the database. Okay. For example, you want to, this is importing it from a website right now, GitHub user. Let's say if I have the data locally stored, let's say this is my data path. And then if I want to import from there the same data set, how do I do that? Path plus this one. First give the path, then give the file name. Then the path seems to be not working. That means I need to exactly find out where is that data set and then give it. Let me adjust this path, then it may work. Let me get that path. So where is that data set? Let's go to Python and then training my Python and then datasets. So here is the path. Let me give that path once again. Is this the same path? It seems that it is slightly changed. Here, here, here. Here you go. Data path and then data path plus the sales by country. File not found. Usually, if it says file not found, generally it means that the path that we entered may be wrong. Okay. So let me get this file, sales by country version 1.csv. So that also I will give it. That should be fine. Even if it says file not found, that means the path that we gave is error. Here, no matter how many times if you execute this will never work. Can you tell me why? No matter how many times, even though I'm giving the right path, a lot of times I have seen students doing this. They will set the path, they will select the path, everything seems to be perfect, but still it will give you an error. The reason is this is not a local system. You're working on Google Colab. There's no way Google Colab can access your data sets. If you're working on Jupyter Notebook, this will work. If you're working on Google Colab, this local path you cannot give. This doesn't work. Make a side note here. This doesn't work. You have to keep it somewhere where Google Colab can access, or you have to use this option of mounting the drive and then you keep it on Google Drive, then get it. Otherwise, directly by giving the right path also, it won't work, isn't it? No matter how many times we try it, it will never work. You have to keep it on shared drive for sure. So how do you import an Excel file? You write pd.read_excel. So let's say World Bank data is what I want to import. World Bank data, that is equal to pd.read_excel. And then mention the complete path. Mention the complete path. Along with that, you also need to mention the sheet name. If you don't mention the sheet name, by default, first sheet will be copied. But not always we are sure that
our data is exactly present in the first sheet. Whichever sheet your data is present, that is the sheet that you have to take. Okay. So I'll mention the file name first. Here is the file name along with the path. So put it in the quotes. There you go. And then comma sheet name. What is the sheet name? Sheet underscore name is equal to sheet one as it is in the actual data set. It has to be mentioned. In some data set, the sheet name is sales. In some data, the sheet name is data, something like that. Whatever is the sheet name that need to be mentioned. Sales data imported, World Bank data imported. There are a couple of more data sets that can also be imported. So what I want to tell you is when you are importing the data, you have to give the path where Google Colab can read from there. Okay. There is a small tip. You can also import the zipped files if you like to. Let's say right now I have a data set called Airbnb zipped file. It's a zip file. What you can do is you can use the same read underscore CSV format. Then you can give the option compressed equal to zip. Okay. Let's say the data set that I have is here somewhere. Okay. So this is the data set that I'm talking about. Let me paste it here. This is the data set that I'm talking about. It is Airbnb New York 2019.zip. But you don't need to unzip it. You can directly copy it, but you have to use an extra option called compression equal to zip. So if you mention data frame name pd.read underscore CSV and mention the complete path, along with that, you just mention compression equal to zip, then automatically that data set will be imported too. If you want to have a look at the data, quickly, if you want to have a look at the data, you can have a look at the data as well. It's not a good idea to print always, but quickly, if you want to have a look at it, you will get a truncated value of the output. Truncated in the sense, you will not get all the rows printed. Top five, bottom five rows will be printed in front of you. You can import the zip files as well. You can import SAS files. SAS is another software. If you are a data scientist, if you're a data analyst working on a platform called SAS or a software called SAS, if you have any SAS files, you can import them into Python, okay, using Pandas itself. Okay, how do you do that? You can use pd.read underscore SAS function. Okay, read underscore SAS, or there is something called pyread stat. As of now, you can skip that step. That may not be important, but this is just for your information. You can use pd.read underscore SAS or pd.read. The package name is pyread stat. Okay. Now let us see some of the basic commands after importing. What I want you to do is I want you to import a bunch of data sets here. There are a hell lot of data sets that we will be using in our course. I want you to import all of them in one shot. All of them I have kept on the Google Drive, except this one. This one we will remove it. Except this, everything else is kept on your GitHub. So all these must be working. I'm importing the sales data, credit card usage data, bank data, online retail sales, King County house price data, Roseman store sales data, Airbnb New York data, auto data, World Bank data, bill data, complaints data, orders data, slots data, everything I'm importing. All the data sets that I'll be using later on, that I'm importing here. Okay, everything, all the data sets I'm importing. Once the data set is imported, printing the full data to get the details, like whether the data is imported correctly or not, whether all the columns are there or not, how many rows are there, how many columns are there, what are the column values, are there any missing values in each of these columns. If you want to get the details of the data, it's not a really good idea to completely print the data. Sometimes even when you print the data, you may not get the complete picture because you will get a truncated output. Sometimes the data is so large that you have thousands of rows, you may have tens or hundreds of columns. You may not get the real picture even after printing the data. So what are those basic measures that you can use to get an idea on the data frame that you have imported? So the first measure is you can write dataframe.shape. Shape is a property of this data frame. If you write dataframe.shape, the output that we got is 998,7. It means that there are 998 rows in this data frame. There are 7 columns. Now, out of these 7 columns also, if you want to see the column names, column types, whether it is a numeric column, whether it's a string column, or how many missing values are there in each of the columns, then you can write dataframe name.info. You can use this function called dataframe.info. There you will get to know data column name 1, column name 2, column name 3. What are the column names? How many non-null values are there? Whether it is integer or object means string object. That's how you will get to know. Or if you're interested in just the column names, nothing else, you don't want any additional information, you simply write dataframe name dot columns. If you simply write columns, you'll get all the column names. You can ignore d type equal to object. That is actually what type of this particular output is. This one you ignore it. These are the column names that you have. If you still want to print the data, because if you want to get even better understanding, if you want to look at a snapshot of the data, you can use this option, dataframe name dot head. If you say dataframe name dot head, the first 5 rows will be printed for you. These are the first 5 rows that are printed. These are all the columns, and 0 to 4, which is like 5 rows printed. If you say dataframe name dot tail, dataframe name dot tail, the last 5 rows in this data frame, they will be printed for you. The last 5 rows, dataframe name dot tail. If you want to print randomly 5 rows, you write the dataframe name dot sample, sorry, dataframe name dot sample, and then how much ever you want. I want 5 rows to be printed. Sorry, it's not dataframe, it's sales dot sample. Sales dot sample. These are sample 5 rows. And whenever I re-execute it, a different sample will be printed. If I re-execute it, a different sample of 5 rows will be printed. If you want to freeze that sample, once you print it, if you want to print it again and again, again and again, the same sample, you can write random underscore state. You can use random underscore state parameter, some number, maybe 55, 61, or 22, or random underscore state is 1, or 10, or 15, any number. If you just give one number, the sample associated with this random state will be same. No matter how many times you execute, it will be same. 823, 774, 933, 722. Again, re-execute it. 823, 774, 933, 40. Same thing. It will not change. In some programming languages, it is known as seed. Here, it is known as random underscore state. Any number can be given here. But if you do not use it, different sample will be printed in every occasion. Different sample will be printed. But here, the same sample will be printed. That is sample, data frame name dot sample. Okay. That is a small checklist that you may have to do right after importing the data. Okay. What we will do is we will do a small exercise right after this. What I want you to do is get into the first exercise, printing the data and getting the metadata information. That is our first exercise. So where is that first exercise? Here is the first exercise. Import credit card usage data. We have already imported. That is there in here. CC usage data, credit card usage data. How many rows, how many columns are there? Don't use print option. Try to use the different option that we discussed. Print only column names. Print the first 10 records. Print the last 5 records. Take a random sample of 300 records and print it. That is what our first exercise. You should be able to do it. Definitely, please go ahead and give it a try. Okay. That's your first exercise within Pandas. Now let us see how to access the values from these data sets. How do you access the rows? How do you access the columns? Once you're done with that exercise, let's get into accessing the rows. So here is my sales data set. If you want to access the first 10 rows, you can use ILOC, stands for index location, and then mention those values 0 to 10. Usually index 10 will be ignored. So index location 0 to 9 will be printed, which is effectively 10 rows, 0 to 9, 10 rows. If you want to specifically access some indices, so you want to access this one as well as index 9 as well as index 7, specifically access those indices, you can say my indexes are, what are my indexes? I would like to access the first one, the 6th index and the 9th index. And then what I'll do is write the data frame name dot ILOC. In that, mention my index. Only those 3 rows will be given to you. Only those 3 rows. Or you can directly, without defining my index also, directly in the place of my index, you can keep it. So it may look like 2 square brackets. The outside one is for accessing. The inside one is for creating a list. That's it. A safer way would be this one, which with lesser confusion. Otherwise, even with 2 square brackets without defining it outside also possible. That's how you access the rows. If you want to access the column names, again, the same way, define the column names. So you come like this and then say my index. Instead of my index, you write my columns. And what are the column names that you want to access? I want to access customer name, customer country, and sales channel. Those are the ones that I want to access. Okay, write them here. Not interested in product sold. Customer name, customer country, and sales channel. They must be in quotes and they must be separated by a comma, followed by this one. And then mention my columns, and ILOC is not required here. When you're accessing columns, it is not index location. Index means these are the row indices. For columns, directly write sales my columns. That should be fine. Column names. You are actually accessing the columns by using their names. Otherwise, you can directly use ILOC. You can use sales dot index location. If you want to access them using column indices, what you can do is you have to give two ones, like the way we have used two-dimensional numpy array. You have to use that format. I would like to take all rows from beginning to the ending, all the rows, followed by which columns you want. You want to access 0 to 4 columns. Okay, first 3 or first 4 columns. If you want to access that, that's how you access the first 4 columns. Or specifically, if you want to access some rows and some columns, so let's say if I want to access the first 10 rows, I'll put 0 to 10 rows, and first 4 columns. That's the option. First 10 rows, first 4 columns. That's how you give it. So you can access using index location, or you can access using the column names. That is also fine. Okay. There is one more option called LOC. ILOC stands for index location. There is something called LOC. Let us see what is the difference. So let's say if you write sales.ILOC and then simply write 20 to 30, it has to be square bracket. Sales.ILOC. This is the output. If you write sales.LOC also, the same output will come. Instead of simply location, instead of index location, it seems to be same output, but there is a difference. There is a slight difference. Let me show you that difference. Let me save this in sales 1. Let me save this in sales 2. Let me save this in sales 1. Let me save this in sales 2. Sales 1 and then sales 2. Now what happens is, let us say from sales 1, okay, from sales 1, sales1 dot ILOC, if I write 0 to 5, that's working. Now, but if I write that same on sales 2, if I write sales 2 on that, if I write LOC 0 to 5, oh, it's not working. Sales 1, sales 2 look the same way, but if I'm using LOC instead of ILOC, it's not working. So index location, it is actually taking the index seriously. So LOC, it's the actual location, the index values or the names. Okay, this LOC, it's not working 0 to 5 because it did not find any index 0, any index 1, 2, 3, 4, 5. That's are not, those are not there because we have taken from 20 to 30. If you would have taken 20 to 25, then it would have worked. LOC. But once the new data is created, sales 2 should not be worried about anything, isn't it? For us, sales 2 contains 10 rows and I'm asking for first 5 rows, it's not working. Okay, that's the problem with LOC. Though sales 1 and sales 2 look the same, but sales 2 is very different. It takes those index values literally. That is the problem. LOC looks at those index values literally. So in simple words, ILOC stands for index location. So whatever is the location of the index, we are looking for that. So basically index location 0 to 5, it doesn't matter what is the index value. Whereas LOC stands for the exact index value. So if you write 0 to 5, it is looking for 0 index, 1 index, 2 index, and so on. Those index values are not there. Index location 0 to 5 works. Index values are not there. Here the index values are 20, 21, 22, and so on. That's the reason why LOC doesn't work. So better to go for ILOC always, because LOC is looking for the exact index or exact values or the index names. Another example would be, let's say if I write sales.LOC 0 to 5, comma 0 to 2 on the whole sales data, this will work. Here 0 to 5 in terms of rows is fine, but in terms of columns, there are no indices like 0, 1, 2, 3, and so on. This has to be column names. So what are the column names? If you give the column names, we have defined somewhere column names, right? My calls. If you give that, so on the sales data, you have 0 to 5 indices are also there. Since you are using LOC, you have to give the exact indices. 0 to 5 indices are there. My calls are also there. This works, okay, on the sales data. But if you do not want to give that, if you want to give simply 0 to 5 as well as 0 to 4, if that is what you want to give, then instead of using LOC, you use index location. Index location 0 to 5, whatever are there. Index location 0 to 4, whichever is the name, doesn't matter. That will be printed. That's the difference. So LOC expects you to give the index value itself. The name of the column is the index value. ILOC asks you to give only index location. Whatever is the name, it doesn't matter. It's simply the index location versus index value. You can think that as ILOC is index location, wherever is the index, and LOC stands for index name or index exact value. That's the major difference between them. Usually better to use ILOC in all the cases to be on the safe side. You can also access columns of one particular type if you are interested in getting only the numeric columns. Let's say if you want to access from the sales dataset, S is uppercase here, sales.select underscore D types. Select underscore D types. What type of columns you want to include? Include the columns of the type int 64. Okay. These are the columns that are the ones that I want to include. Only keep them. You can actually save them in a new data frame as well. But as of now, I just want to print it. So I will say sales select D types include is equal to of this type index. Integers are of this type. Or if you want to include two different type integers as well as float 64, integer 64 or float 64, that is also fine. There are only two numerics. If you want to include object types, if you want to select non-numeric ones, then you can take select include values that are of object type. These are all the non-numerical variables. All of them are non-numeric. Or if you want to exclude, that is also fine. If you want to exclude all the object types, that means these 5 columns will be excluded, remaining everything will be included. Remaining column types will be selected. There will be 2 columns that are numeric. I'm ignoring the non-numeric columns. That's how you can use include or exclude when you are selecting. Or if you want to drop a particular set of rows from the data set, how do you drop a particular set of rows? For example, if you take World Bank data, the World Bank data looks like this. It has country, rank, country, GDP, country code, rank, country name, GDP. What if I want to select rest all rows except the top 10? I want to drop the first 10 rows. How do you do that? You use a function called drop. So WB data, if you want to update, you can update our WB data 1 equal to WB data dot drop. And whatever you want to drop, you just mention that I want to drop first 10 rows, a range of 0 to 10. What it will do is that will make sure that every other record is selected except the first 10. From the 10th one onwards, Canada, Australia, Korea, Mexico, all those things, or Spain, Mexico, all those columns are coming up there. That's how you can drop particular. Not only that, if you want to drop a particular set of rows, let's say World Bank data 2, if I want to drop that particular list of values where first row or fifth row or 10th row, that particular range or that particular list also can be mentioned here. So let us mention, let's say I want to drop at the index 0, at the index 4, at the index 8, at the index 10. These are the rows that I want to drop. I want to keep everything else. Then these 4 first row and all that will be stopped, and remaining will be dropped. Okay, remaining will be kept. These 4 rows are dropped. Okay, record 0, record 4 is dropped after that, and then record 8 will also be dropped. Okay, remaining all will be kept. That's how this drop command works. If you want to drop columns, it's a slightly different one. Let's say from the same World Bank data, if I want to drop country code, I'm not interested in country code. What I have to do is I have to write World Bank data and then here dot drop, and then I have to say country code, country underscore code. Okay. Now what happens here is if you execute it, it will not work, because when you're dropping the columns, you have to give an option called access is equal to 1. That means to tell that you're dropping a column, you have to tell Python that access is 1. If you're dropping a row, you have to drop the row indices. You have to give the row indices. Let's say if you're dropping a row, the option is while you're dropping rows, The option is mention the row that you want to drop and mention axis equal to 0. Then the rows will be dropped. When you're dropping a column, you have to mention the column, mention axis equal to 1. If you don't mention any axis, let's say I did not give any axis, by default axis is taken as 0. That means by default rows will be dropped. So that means if you execute this and if you try to execute this, basically internally axis equal to 0 is assumed. Automatically axis equal to 0 is assumed. Obviously this column is not in axis equal to 0. That is wrong. Even if you don't mention anything, that is also wrong. Why it is wrong? Because x equal to 0 is wrong, because x equal to 0 is default value. If you put x is equal to 1, that particular column will be dropped. X equal to 0. X equal to 0 for rows, x equal to 1 for columns. That's how you use for accessing the data. What I want you to do is, let us do a small exercise now. Let's do the lab exercise. The second part of the lab exercise, accessing the data, accessing the rows, accessing the columns. So here is the data set, bank, telemarketing data, import it. Try to do all these exercises one by one, one by one, one by one, all of them. You will be able to do them because just now we have understood these concepts and these are not very difficult to understand. Just practice them using this exercise. You should be able to do it.
Continue with the next video in the playlist. We are covering everything step by step. If you have any questions or the comments, please post them in the comments window below.